Right now, as you're watching this, something enormous is building. Not in some distant corner of the world, not in a far-off ocean basin that has nothing to do with your daily life. It is building right here, right over American soil and American water, drawing energy from a Gulf of Mexico that is warmer than it has any right to be at this point in the year, pulling in moisture from the south and cold air from the north, and the atmosphere where those two forces collide is becoming an engine of extraordinary and dangerous power. Millions of people live in the path of what is now developing. Some of them do not yet know it. Some of them have already heard the warnings and are quietly preparing, and some of them have lived through storms before and are thinking it will not be that bad, it never is. But the meteorologists sitting in front of their computer screens right now, watching the data pour in from satellites and weather balloons and Doppler radar networks spread across the continent, they are not using casual language. They are using words like volatile and outbreak and high-risk corridor. And when the scientists who study these systems for a living start using that kind of language, the rest of us need to stop and listen. Welcome to Sky Space Lab. I am Arthur. This channel is very new, and every like and subscription truly helps us grow and bring you even deeper, more powerful research. Thank you in advance for every like and follow. To understand why what is happening right now matters, we have to understand what kind of atmosphere we are currently living inside. The United States in late May and early June sits at the center of one of the most meteorologically unstable regions on the face of the Earth. There is no other place like it on the planet. Nowhere else does warm, thick, deeply saturated air from a tropical sea push this far northward into a continent. Nowhere else does cold, dry air drop down from Arctic regions with this kind of regularity and this kind of force. And nowhere else do those two vastly different air masses collide in a landscape this flat, this wide, and this unobstructed. The result, which generations of scientists have studied and which remains one of the most dangerous natural phenomena on Earth, is the American severe weather season. And right now, that season is not winding down. It is accelerating. The Storm Prediction Center, which is the division of the National Weather Service dedicated entirely to tracking and forecasting severe convective weather across the United States, has been issuing a steady stream of elevated outlooks in recent weeks. These are not routine forecasts. The Storm Prediction Center does not use language lightly. When their meteorologists sit down and classify an area under an enhanced risk, a moderate risk, or a high-risk designation, they are communicating something specific and measurable to emergency managers, first responders, and the public. They are saying that the atmospheric conditions in that zone have crossed a threshold where severe weather is not merely possible but expected, in some cases inevitable, and in the worst cases potentially catastrophic. What has been building across the central and southern United States over these final days of May and into the first days of June 2026 is not a single isolated storm. It is a pattern. It is a sustained and repeating atmospheric setup that keeps reloading the same regions with the same ingredients, over and over, day after day, in a cycle that meteorologists find deeply concerning. The Storm Prediction Center's official Day 4 through Day 8 convective outlook, issued in the pre-dawn hours of May 28th, made the situation clear in technical but unmistakable terms. For much of the coming period, an upper trough is forecast to reside over the northeast, while high pressure builds over the Great Lakes and much of the Midwest and Mid-Atlantic. That might sound benign. But west of that surface high, southerly winds across the plains are maintaining a moist air mass with dew points already sitting in the mid-60s to mid-70s Fahrenheit, a level of atmospheric moisture that experienced storm chasers describe as oppressive, heavy, loaded. When you stand outside on a day when the dew point is in the 70s, your sweat does not evaporate. The air is simply too saturated to accept any more moisture. And that saturated air, when it is lifted, when a cold front or a dry line or an outflow boundary forces it upward into the atmosphere, releases energy in quantities that are almost incomprehensible. The numbers that atmospheric scientists use to measure this energy are called convective available potential energy, or CAPE. Think of CAPE as the fuel in the engine. A typical summer thunderstorm might develop in an environment with 1,000 or 1,500 joules per kilogram of CAPE. That is enough to produce heavy rain, lightning, and gusty winds. The kinds of storms that can wreak havoc on a neighborhood, but that, in isolation, are not particularly unusual. But the environments that are being forecast across the Nebraska, Kansas, Oklahoma, and Missouri corridor over the coming days are not showing 1,500 joules per kilogram. They are showing 3,000, 4,000. In some of the more extreme model runs, values approaching 4,500 joules per kilogram are appearing. Those values do not produce ordinary thunderstorms. Those values produce supercells, long-lived, organized, rotating thunderstorms that can persist for hours, travel hundreds of miles, and produce tornadoes of extraordinary power and duration. This is not a new phenomenon for this region of the country. The central United States has always been tornado country. The informal geography of Tornado Alley, that swath of territory stretching from central Texas through Oklahoma, Kansas, Nebraska, and into the Dakotas, has earned its name through decades of documented destruction. But in 2026, something about the pattern has felt different, more persistent, more relentless, and more geographically extensive than what historical averages alone would suggest. The National Weather Service Chicago Forecast Office noted as early as April that the lower Great Lakes region had already experienced 11 separate severe weather events, with at least one documented severe report in a span of time when the historical average would be closer to 4. A corridor running from eastern Iowa through southern Wisconsin and northern Illinois has been described by NWS forecasters as remarkably active, a phrase that carries weight coming from scientists trained to use conservative language. To appreciate why 2026 has taken on this character, you need to understand the large-scale climate forces that are shaping the atmosphere at this moment. The Climate Prediction Center has been tracking a 61% probability that El Niño will emerge or strengthen between May and July, with expectations that it will be in full swing and potentially strong at the traditional peak of the Atlantic hurricane season. In a classic El Niño year, the changes in sea surface temperatures across the Pacific alter the behavior of the jet stream over North America. Upper-level wind patterns shift, the pathways along which low-pressure systems develop and travel change, and critically, the amount of wind shear available in the atmosphere, that change in wind speed and direction with altitude that provides the rotational energy for tornadoes, is affected across the entire continent. But El Niño is only one piece of this story. The Gulf of Mexico, that warm and generous southern boundary of the American continent, has been running above average temperatures this spring. Warmer Gulf water means more evaporation. More evaporation means more moisture available to be transported northward by the southerly low-level jet that acts as a kind of atmospheric highway running from the tropics to the heart of tornado country. Every night, when the sun goes down and the boundary layer stabilizes, that low-level jet strengthens, pumping warm, humid air northward with remarkable efficiency. By morning, the lower atmosphere across Kansas and Nebraska and Iowa and Missouri is loaded with moisture that was not there the evening before, and then the sun rises, the ground heats, the cap that has been holding back convection begins to erode, and the storms fire with the violence of a system that has been coiling itself tighter and tighter all night long. The outbreak that ran from May 16th through the 19th of this month illustrated exactly how dangerous this pattern can be. The Storm Prediction Center placed portions of Nebraska, Missouri, and Kansas under a moderate risk designation for that Sunday, with a 15% tornado probability and explicit concern for EF3 or stronger tornadoes in the forecast. A particularly dangerous situation tornado watch, the highest category of tornado watch that the National Weather Service issues, was activated for portions of Nebraska and Kansas. A tornado emergency, an even rarer and more specific product issued only when a confirmed violent tornado is threatening a populated area, was declared for Pawnee City, Nebraska. 33 tornadoes occurred during that outbreak. An EF3 tornado struck St. Library, Nebraska, with winds of 160 miles per hour. Supercells that had been drawing energy from that enormous reservoir of Gulf moisture produced hailstones in the Kankakee, Illinois area, measuring 5 to 6 inches in diameter. Reports that, if confirmed by the National Weather Service survey teams, would break the former Illinois state record for hailstone size. One person was killed in Kankakee itself, 2 more in Lake Village, Indiana, where the same supercell crossed the state line. These are not statistics, these are communities. These are families whose lives change permanently in the span of a few minutes, while a rotating column of air tore through their neighborhoods at speeds that exceed the maximum capacity of a NASCAR vehicle. And the atmosphere that produced those events has not fundamentally changed. It has not rearranged itself into a safer configuration. The same upper-level trough, the same Gulf moisture, the same daily reloading cycle is persisting into the final days of May, and the forecast models are showing no indication of a significant pattern change as we cross into June. The Storm Prediction Centre's extended outlook for the period running from May 31st through June 5th describes an upper trough forecast to reside over the northeast, while high pressure sits over the Great Lakes. West of that surface high, the southerly flow continues, the moist air mass persists. The mid-levels remain relatively cool, supporting steep lapse rates, which means the atmosphere will continue to favour strong instability during the peak heating hours of the afternoon. The official language from the SPC forecast discussion is precise and clinical, but the implication is clear. Areas of strong to severe thunderstorms appear likely on a daily basis across much of the plains. Cities like Wichita, Omaha, Des Moines, and Kansas City are being named explicitly by weather services as locations that could see severe storms for multiple consecutive days. That kind of repeated hammering of the same regions compounds the danger dramatically, because infrastructure weakened by one event is far more vulnerable when the next system moves through. What makes this setup particularly worthy of serious attention is the fact that the 2026 severe weather season has already demonstrated an unusual appetite for violence at its lower end of frequency, but higher end of intensity. Colorado State University's seasonal forecast, released on April 9th, projected 13 named storms in the Atlantic with 6 hurricanes and 2 major hurricanes, running somewhat below the long-term average. NOAA's official seasonal outlook for the Atlantic aligns with that assessment, calling for 8 to 14 named storms and noting the presence of El Niño as a moderating influence. But the same NOAA scientists who are offering that relatively restrained Atlantic hurricane forecast are also the ones watching the continental pattern with close attention, because the anomalous warmth of the Gulf of Mexico and the persistent southerly flow that has characterized this spring are factors that influence both the Atlantic basin and the inland severe weather setup simultaneously. The ocean does not know or care about the distinction between categories of weather disasters. It simply evaporates, feeds moisture into the atmosphere, and lets the thermodynamics take over. And the thermodynamics right now are pointing toward continued danger. AccuWeather senior meteorologist Courtney Travis, commenting on the multi-day outbreak system that has been carving its path across the United States, described the atmospheric setup as particularly volatile. The combination of strong high-altitude winds, surging moisture from the Gulf, and sharp temperature differences create the primary drivers for tornadoes, large hail, and destructive wind gusts. That combination is not going away. The temperature contrast between the air masses is sharpening as summer approaches, and the differential between the warm, humid south and the still relatively cool north reaches its seasonal peak. The jet stream, which provides the upper-level wind shear that organizes supercells and keeps them rotating, is positioned in a way that maximizes its influence over precisely the regions that are already being battered. There is also the question of the derecho threat, which deserves its own careful consideration, because it is frequently underestimated by the public compared to the more visually dramatic and culturally iconic tornado. A derecho is a widespread, long-lived windstorm associated with a line of severe thunderstorms, where a tornado is a localized, intensely focused vortex that might carve a path a mile wide for 20 minutes. A derecho can produce hurricane-force straight-line winds across a corridor hundreds of miles long and persist for many hours. The damage from a derecho can equal or exceed that of a tornado outbreak, because the area affected is so vastly larger. AccuWeather's forecast team has highlighted an increased likelihood of severe thunderstorms, packing damaging wind gusts and heavy downpours, as one of the defining characteristics of the 2026 season, with flash flooding singled out as a particularly elevated concern. Derechos are most common in late spring and into summer, which places us squarely within the period of maximum risk right now, in these coming days and weeks. The science of how these storms form is, in its own way, a remarkable story. To understand why the central United States is uniquely vulnerable to the violence currently gathering in the atmosphere, you have to start with the geography. The Rocky Mountains rise abruptly from the western high plains, acting as a barrier that forces air masses to interact in specific and predictable ways. West of the Rockies, the air is different, drier, often cooler at the surface, modified by its long passage over mountain terrain. East of the Rockies, the Gulf of Mexico reaches its long, warm arm northward across a continent that offers no geographical obstacle for hundreds of miles. The flat, open terrain of the Great Plains is the stage on which these two fundamentally different air masses meet, and the meeting is never quiet. The dry line, one of the most important meteorological features in the world of severe weather forecasting, is the boundary where the dry western air and the moist Gulf air come into contact. Along the dry line, which typically runs roughly north to south, across the central plains on active severe weather days, the atmosphere is under enormous stress. On one side, you have air that might have a dew point of 50 degrees Fahrenheit. On the other side, barely 20 miles away, you have air with a dew point of 72 degrees. The difference in moisture content between those two air masses is staggering. Where they meet, convergence forces air upward. And when that moisture-laden Gulf air is lifted, the water vapor within it condenses, releases its latent heat, and the updraft accelerates. What starts as a gentle rise becomes a rocket. What begins as a cumulus cloud with a flat base becomes, in the right wind shear environment, a rotating supercell with an updraft powerful enough to suspend baseball-sized hailstones for minutes at a time before hurling them to the ground with the force of a fastball. This is the physics that is operating right now across the heartland of America. It is not theoretical. It has already killed people in this calendar year. The tornado outbreak sequence of April 23rd through the 28th swept across the southern plains and produced a level of destruction that emergency managers in multiple states described as one of the most challenging response environments they had ever faced. The outbreak of early to mid-May added dozens more confirmed tornadoes to the 2026 total, and the late May outbreak centered on Nebraska and Kansas produced the EF3 at St. Libury and the records-challenging hail in Illinois. The pattern has not broken. The atmosphere has not reset. The ingredients are still there, still combining, still capable of producing events of equal or greater severity in the days that lie directly ahead. What the Storm Prediction Center's extended forecasts are showing for the period beginning this coming Sunday and running through the following Thursday is a continuation, and in some respects an intensification of the pattern. A weak but negatively tilted trough shifting slowly northward across the northern plains and Rockies will provide the necessary trigger mechanism for storm initiation. The word negatively tilted is significant to meteorologists because it describes a specific orientation of the atmospheric wave pattern that is particularly efficient at generating severe weather. A negatively tilted trough enhances the extraction of instability from the atmosphere, intensifies wind shear, and supports the development of the most organized and dangerous storm modes. When forecasters see a negatively tilted trough approaching a region already primed with high CAPE and deep moisture, they pay very close attention. And there is something else in the coming pattern that deserves careful consideration. The proximity of the forecast storm activity to major metropolitan areas is not trivial. The corridor from central Kansas through Missouri and into the Illinois-Indiana border region is not empty farmland, though the farmland itself matters enormously to the food security of this nation and to the families who work it. It is also a region containing significant urban and suburban populations. Wichita is a city of nearly 400,000 people. Kansas City, straddling the Kansas-Missouri border, is a metropolitan area of more than 2 million. St. Louis adds another 2.5 million to the risk footprint. Indianapolis, which sits on the eastern edge of the recurring threat zone, is home to another 2 million. When the atmosphere generates a violent supercell or a long-track EF3 tornado in a sparsely populated agricultural area, the damage is devastating, but the human toll, while never zero, is often limited by density. When the same supercell crosses the line into a suburban zone where houses are packed closely together and basements are not universal, and mobile home parks represent the housing option for tens of thousands of residents, the human consequences change dramatically. The National Weather Service is acutely aware of this geographic reality. The new 2026 Operational Forecast Cone graphic, implemented by the National Hurricane Center this season, which now includes tropical storm and hurricane watches and warnings for inland areas for the first time, reflects a broader institutional recognition that the threat boundary between coastal and inland, between one type of severe weather and another, is increasingly artificial. The Storm Prediction Center's own new Conditional Intensity Group system, debuted in February of this year and representing what NWS meteorologist Evan Bentley described as a smarter way to be prepared and stay safe, adds a second layer of information to existing outlooks that specifically flags areas at risk for the most violent and extreme severe weather, the EF3 and above tornadoes, the winds exceeding 90 miles per hour, the hail larger than 2 inches in diameter. The goal of these new tools is to communicate not just that severe weather is possible, but how severe it could be if it occurs. This distinction matters enormously for public preparedness. When a region is told that severe weather is possible, the response from many people is essentially the same as no response at all. Severe weather has been possible on most spring afternoons across the southern and central plains for as long as anyone has been keeping records. It is background noise, it is the weather. But when forecasters can say specifically that the environment supports EF3+ tornadoes, that wind gusts of 90 or more miles per hour are credible threats, that the hail could reach sizes capable of destroying a vehicle's windshield or puncturing a roof, the message changes. The urgency becomes real in a way that abstract probability numbers alone do not convey. I want to pause here and say something directly, because I think it matters in a conversation like this one. The information we are presenting is drawn from official National Weather Service forecasts, Storm Prediction Center outlooks, NOAA seasonal assessments, AccuWeather meteorological analysis, and the scientific literature around atmospheric dynamics. The numbers and risk descriptions you're hearing are real, and they come from the scientists whose professional lives are dedicated to understanding and communicating exactly these threats. But weather forecasting, even at the highest levels of scientific sophistication, is probabilistic. It deals in likelihoods, not certainties. The atmosphere is a chaotic system, and the models that help us understand it are extraordinary tools but not crystal balls. I would always encourage you to cross-check what you hear here with your local National Weather Service office, with the Storm Prediction Center's own public products, and with the meteorologists at your trusted local television stations who know the specific geography and climatology of your community, far better than any national overview can capture. The goal is to give you the framework, the context, the deep background that helps you understand why the warnings matter. What you do with that information, and how you verify it for your specific situation, is always your own independent responsibility. With that said, let us go deeper, because understanding the current threat is only the beginning of the story. To truly understand why the American severe weather season operates the way it does, why it produces events of such concentrated and relentless violence in a pattern that repeats year after year, you have to understand the mechanisms that govern it at the deepest level. The supercell thunderstorm is the most important single storm type in the American severe weather ecosystem. It is the engine of the most significant tornadoes, the largest hail, the most intense wind events. And it does not form randomly. It forms in environments where three specific ingredients come together in the right proportions and in the right configuration. Those ingredients are moisture, instability, and wind shear. We have talked about moisture and instability already, the Gulf of Mexico feeding humidity northward, the steep lapse rates and high CAPE values that tell us the atmosphere is loaded and ready. But wind shear is the ingredient that takes a disorganized collection of thunderstorm updrafts and turns them into a coherent, organized, long-lived rotating system. And right now, the wind shear values being observed and forecast across the central plains are remarkable. Wind shear, for those who have not encountered the concept before, describes the change in wind speed or direction as you move upward through the atmosphere. In the lowest levels, below about 3 kilometers, the wind might be coming from the south at 15 miles per hour. At 6 kilometers, it might be coming from the southwest at 50 miles per hour. At 9 kilometers, from the west at 80 miles per hour. That systematic backing and increasing of the wind with height creates horizontal vorticity, essentially tubes of rotating air oriented horizontally within the atmosphere. When a powerful updraft tilts those tubes of rotating air into the vertical, it creates the rotation in the storm's core that can eventually tighten and amplify into a tornado. The stronger and deeper the wind shear, the more organized and long-lived the supercell can become, and the environments being observed across the plains right now are showing effective bulk shear values that meteorologists describe as supportive of the most intense storm modes. There is a measurement called the Significant Tornado Parameter, a composite index developed at the Storm Prediction Center that combines several atmospheric variables into a single number designed to estimate the likelihood of significant tornadoes, defined as EF2 or stronger. In environments where the significant tornado parameter exceeds 1, tornadoes are increasingly likely. Where it exceeds 3, the risk of violent tornadoes begins to emerge. In some of the model forecasts for the coming week across the Central Plains corridor, the significant tornado parameter values being projected are not in the range of 3 or 4. They are approaching, and in some grid cells exceeding 10. These are not routine numbers. They are the kind of numbers that make experienced severe weather meteorologists lean forward in their chairs and look more carefully at what the other models are showing. The forecasting community in 2026 has access to tools that would have seemed extraordinary to their predecessors even 20 years ago. The dual polarization radar network that was rolled out across the United States in the early 2010s transformed the ability of NWS meteorologists to see inside storms in real time, distinguishing between rain and hail, identifying the debris signature that confirms a tornado has touched the ground and is lofting objects into the air, tracking the rotation within a supercell's mesocyclone with a precision that was previously impossible. High-resolution numerical weather prediction models, running on some of the most powerful supercomputers in the world, now resolve individual convective cells at grid spacings of 3 kilometers or less, allowing forecasters to see the probable timing, location, and intensity of individual storm clusters hours before they develop. The NOAA goes 18 and goes 19 satellites, operating in geostationary orbit, provide continuous real-time imagery of the entire continental United States with a temporal resolution measured in minutes, allowing meteorologists to track the development of convective initiation in near real time and issue warnings with more lead time than any previous generation of forecasters could achieve. And yet, despite all of this technological sophistication, storms still kill people. They kill people because the warning system, remarkable as it is, requires that people receive the warning, understand it, take it seriously, and have somewhere safe to go. The average lead time for a tornado warning in the United States today is approximately 13 minutes. 13 minutes is not a long time. If you're in a vehicle on a rural highway with no shelter in sight, and a wedge tornado is crossing the road ahead of you, 13 minutes does not solve your problem. If you live in a mobile home, as millions of Americans do, 13 minutes gives you barely enough time to get out and find a more substantial structure. If you're asleep when the warning is issued at 2 in the morning, 13 minutes may not be long enough for the alert to wake you, register its significance, and translate into protective action. This is why the storm that is gathering across America right now is not simply a meteorological event. It is a test of public preparedness, community resilience, and the reliability of communication systems that connect the science to the people at risk. The National Weather Service has invested heavily in the Weather Ready Nation program, which seeks to build a culture of preparedness throughout the country, not just in the communities that have recently been struck, but in all communities that face recurring threats. The principle behind it is that preparedness cannot be a reactive behavior, something you do after the last storm scared you into action. It has to be a baseline posture, something that is maintained continuously throughout the season, so that when the warning comes, the response is automatic and practiced rather than panicked and improvised. For the tens of millions of people living within the threat corridor that the Storm Prediction Center's extended forecasts are outlining for the coming 10 days, that principle is directly relevant right now. Cities from Wichita to Kansas City to St. Louis to Chicago and Indianapolis are all sitting within the recurring zone of elevated risk. The daily pattern of Gulf moisture loading, afternoon destabilization, storm initiation, and overnight reloading is not going to break cleanly before June. The models are not showing a reinforcing cold air outbreak that would scour the moisture out of the region and reset the atmosphere to a calmer configuration. What they are showing instead is day after day of storm potential, with individual events separated by enough recovery time for the moisture to rebuild, but not enough for the threat to meaningfully decrease. The question that every person living in this corridor needs to be asking right now is not whether a severe storm will affect their community this season. At this point in the season, with this pattern in place, that question has already been answered. The question is, what happens when it does? Do you have a weather radio with fresh batteries that will wake you if a tornado warning is issued in the middle of the night? Do you know where you're going to shelter if a warning is issued while you're at work, at school, or in a vehicle? Have you walked through your home and identified the interior room, on the lowest floor away from windows, that offers the best protection from flying debris? Have you talked to your children about what to do, and practiced the plan often enough that it is reflexive rather than remembered? These are not frightening questions, they are practical ones. The science of severe weather preparedness has repeatedly demonstrated that the single most important factor in whether a tornado kills or injures the people in its path is not the tornado's intensity, and it is not the warning lead time. It is whether the people in the path have a plan and execute it. Communities with strong preparedness cultures and high weather awareness consistently survive even violent tornado events, with lower casualty rates than communities of comparable size that lack those foundations. The Storm Prediction Center's new conditional intensity groups, the upgraded forecast cone graphics from the National Hurricane Center, the continued expansion of NOAA's flood inundation mapping services to nearly 100% of the US population by late September of this year, all of these are tools designed to close the gap between what the science can see coming and what the public understands about the threat it faces. The Atlantic hurricane season adds another dimension to this already complicated picture. NOAA's official outlook for 2026 calls for 8 to 14 named storms, 3 to 6 hurricanes, and 1 to 3 major hurricanes in the Atlantic basin. Colorado State University's independent forecast, released in April, projects 13 named storms, 6 hurricanes, and 2 major hurricanes, with an accumulated cyclone energy value of 90, compared to a historical average of 123. These numbers suggest a below-average season in terms of raw activity, and the likely development of a strong El Niño through the peak of hurricane season is the primary reason for that assessment. El Niño suppresses Atlantic hurricane activity through several mechanisms, most importantly by increasing vertical wind shear over the Atlantic, which disrupts the organized deep convection that tropical systems need to intensify. In a strong El Niño year, storms that might otherwise develop into major hurricanes can be torn apart by the wind shear before they reach their peak intensity. But the scientists delivering these forecasts are careful to frame them in a specific and important way. NOAA Administrator Neil Jacobs put it directly. Even though we are expecting a below-average season in the Atlantic, it is very important to understand that it only takes one. AccuWeather, whose forecast sits at the higher end of the range with 11 to 16 named storms and 3 to 5 direct US impacts projected, echoes the same theme. Preparedness is critical. The Bermuda High, a semi-permanent area of high pressure over the western Atlantic that plays a crucial role in steering tropical systems, is forecast to sit somewhat farther south and east this year, a configuration that may allow more storms to curve away from the US coastline, but may is not will. The steering patterns that drive tropical storms toward or away from land are notoriously difficult to forecast weeks in advance, and a storm that develops close to the coastline in the Gulf of Mexico or the Western Caribbean has very little distance to travel and very little time for steering patterns to divert it. The threat landscape that confronts the United States right now, in these final days of May 2026, is therefore not a single threat but a layered one. There is the immediate present tense threat of severe thunderstorm and tornado outbreaks across the central and southern plains, the Midwest, and potentially the Ohio Valley as the recurring pattern continues. There is the developing but still building threat of the Atlantic hurricane season, which has officially begun and which, even under the most favourable projections, will deliver multiple named storms and at least one potentially direct US impact. And there is the background threat of the hydrological consequences that accumulate across a region hit repeatedly by intense precipitation events, where soils are already saturated, rivers already running high, and the capacity of the landscape to absorb additional rainfall is compromised in ways that dramatically amplify the flash flooding risk from any individual storm event. The Texas Hill Country, for example, which sits on the eastern edge of the recurring severe weather corridor, was mentioned explicitly in AccuWeather forecasts as still recovering from catastrophic floods when the latest high-risk outbreak targeted the region in recent weeks. Flash flooding is already on AccuWeather forecaster Alex Duffus's list of primary concerns for the 2026 season, described as a big concern this year given the atmospheric pattern. When a supercell thunderstorm drops 4 inches of rain in 45 minutes on a watershed already saturated from the previous week's events, the resulting flood is not 4 times worse than what 4 inches on dry ground would produce. It is 10 times worse, or 20. The nonlinearity of flood response to rainfall on saturated ground is one of the most dangerous and most underappreciated aspects of a sustained severe weather pattern. This is why the conversation about the storm targeting America right now has to encompass more than wind speeds and tornado ratings. It has to include the water, the floods, the creeks and rivers and dry washes that transform from benign landscape features into killing machines in a matter of minutes when the right storm parks over the right watershed at the right time. The National Weather Service's 2026 expansion of its high-resolution flood inundation mapping services, which will cover nearly 100% of the US population by late September, is a direct response to the recognition that flood deaths in this country are preventable, and that the tools to prevent them, the real-time visualization of which specific streets and neighborhoods are going underwater, are now within technical reach. But those tools only save lives if people are watching, listening, and responding. The storm is not waiting. The atmosphere is already loaded. The Gulf moisture is already flowing northward. The instability is already building in the afternoon heat of the southern plains. And somewhere between now and the end of the first week of June, the trigger mechanism that the SPC's extended forecasts have been tracking, that weak negatively tilted trough shifting northward across the northern plains and Rockies, will arrive and interact with the primed air mass in a way that the science can see coming, but cannot yet fully define. When it does, the towns in its path will have their 13 minutes, their weather radios will alarm, their phones will buzz with emergency alerts. The question is not whether the storm is coming, the question is whether the people in its path will be ready. And the people in its path need to understand something that the models and the outlooks and the probability maps do not always communicate with the emotional clarity that the situation demands. The storm season does not pause while communities grieve and rebuild. It does not respect the timeline of insurance adjusters or the schedule of FEMA disaster declarations. It runs on atmospheric physics, not human convenience, and the physics right now says the threat is not receding. It is shifting northward as the calendar moves deeper into June, as the jet stream retreats toward its summer position, and the zone of maximum storm potential migrates from the southern to the central, and then the northern plains. This is the climatological progression that has defined the American severe weather season for as long as records have been kept. The peak tornado risk for central Texas to eastern Nebraska typically falls in May. For Nebraska and the Central Plains, it extends into June. For the northern plains and Midwest, July. The season does not end, it moves. This northward migration of the storm track carries its own particular dangers that differ from those of the southern plains season. As the jet stream lifts toward Canada, the storms that develop along its southern edge tend to form in environments with somewhat less deep moisture than the Gulf-driven setups of April and May. But they often compensate with extraordinary wind shear. The upper-level winds in early summer can be extreme across the northern tier states, and when those winds interact with even modest low-level moisture and afternoon heating, they can produce supercells with mesocyclones that are among the most violently rotating in the world. The 2025 season provided a vivid reminder of this when a June tornado outbreak across the northern plains produced an EF5 tornado near Enderlin, North Dakota, with winds estimated in excess of 210 miles per hour, one of the highest wind speed estimates ever recorded in a tornado. That event killed 6 people and produced a derecho that swept into the northeastern United States with gusts exceeding 120 miles per hour in Minnesota, before eventually dissipating over New York State. The northern tier in summer is not a safer place. It is simply a different kind of dangerous. The forecasting analysis published just days ago, assessing what June 2026 may bring, laid out the atmospheric logic with admirable precision. As the jet stream retreats north in early summer, it can still send disturbances over the Rockies and plains. Lee troughing east of the Rockies draws Gulf moisture northward. When that humid air overlaps with steep lapse rates, strong instability, and enough low-level wind shear, supercells can form. If storms stay discrete, tornado and very large hail risk rises. If storms merge into a line, the main threat shifts toward damaging straight-line winds, derechos, and flash flooding. That conditional logic, the distinction between a discrete supercell environment and a linear storm mode environment, is one of the most consequential forecast decisions that meteorologists have to make in the days leading up to a major event. It determines which hazards are most likely, it shapes the geographic footprint of the warning area, and it changes the type of shelter behavior that will save lives versus the type that will not. A tornado and a derecho demand different responses in some ways, though they share the fundamental requirement of moving to a sturdy interior low-level location and staying away from windows. What changes is the geographic scale of the threat. A tornado warning covers an area of perhaps a few square miles at any given moment as the vortex tracks across the ground. A severe thunderstorm warning for a derecho can cover a corridor that is hundreds of miles wide and still accelerating. The psychological challenge of responding appropriately to a derecho is that many people do not take straight-line wind events with the same seriousness they give to tornado warnings, even though the winds in the most intense derechos can equal or exceed those in EF2 and EF3 tornadoes. The differentiation that the Storm Prediction Center's new conditional intensity groups bring to public communication is precisely intended to address this gap, to make visible the severity of events that probability alone does not adequately convey. Something else deserves direct attention here, and it is a dimension of the storm threat that the raw forecast numbers often fail to capture. The communities that are sitting within the recurring severe weather corridor of 2026 are not all equally equipped to respond, recover, and rebuild. Some of them are cities with professional emergency management departments, well-staffed National Weather Service forecast offices nearby, robust shelter infrastructure, and populations with relatively high rates of weather awareness. Others are small rural communities where the county emergency manager is a part-time position held by someone with 15 other responsibilities, where the nearest NWS office is 3 hours away, where the housing stock includes a high proportion of manufactured homes and older structures that are genuinely dangerous in even a moderate tornado, and where the population includes elderly residents, people with mobility challenges, and families with young children who depend on others to make protective decisions on their behalf. The gap in storm mortality outcomes between communities with strong preparedness infrastructure and those without it is not small. It is large, and it is well documented in the scientific literature on tornado fatalities. The same EF2 tornado that passes through a well-prepared suburban community with high basement ownership rates and a population accustomed to acting quickly on warnings can produce 0 fatalities. A functionally identical tornado tracking through a rural community with high mobile home density and low weather radio penetration can kill dozens. The physics of the storm do not change. The human context changes everything. As we stand right now, in the last days of May 2026, with the severe weather pattern showing no signs of fundamental change, with the Atlantic hurricane season officially open and the first potential areas of organized convection already being monitored in the tropics, with flash flooding risk elevated across saturated basins from Texas to Indiana, the single most important thing that any American living in a threatened region can do is precisely what the meteorologists and emergency managers have been asking for decades. Make a plan, know your shelter location. Have your weather radio, charge your phone, know your evacuation route if you live in a flood-prone area. Know the difference between a watch and a warning, and know that by the time a warning is issued, you should already be in your shelter, not pulling on your shoes. The mechanics of what comes next in this pattern are worth tracing carefully, because the transition from late May into June is not simply a continuation of what has already occurred. It is a reshaping of the threat landscape in ways that can catch communities off guard precisely because they assume the worst of the season has passed. The last day of May historically sits at the statistical peak of the tornado season for the Central Plains. June 1st by the calendar feels like a turning point. The calendar is wrong. The atmosphere does not recognize June 1st as a transition. What it recognizes is the position of the jet stream, the temperature of the Gulf, the orientation of the upper-level trough, and the moisture content of the boundary layer. And on all of those metrics, the environment that will greet the opening days of June 2026 is indistinguishable from the environment that produced the deadly outbreaks of late May. There is a psychological phenomenon that emergency management professionals have observed and documented across many disaster contexts, a kind of collective relaxation that sets in after a major threatening event has passed without directly hitting a given community. Researchers who study risk perception call it the near-miss effect. When a community watches a tornado outbreak on the news and the tracks stay 50 miles away, the visceral sense of personal vulnerability that was briefly elevated tends to drop below its baseline level. People feel not just relieved but somehow protected, as if the storm's failure to strike them was evidence of a kind of geographic immunity rather than simply the probabilistic outcome of a storm that happened to track north of their location rather than south of it. This psychological dynamic is particularly concerning in a season like 2026 because the repeated major outbreaks in Nebraska, Kansas, and the Midwest have been generating precisely this pattern of near-miss experiences for communities that sit adjacent to the paths of the confirmed violent tornadoes. There is also the matter of wildfire risk, which adds a second dimension to the threat picture that is easy to overlook when the dominant storyline is tornadoes and flooding. The same storm systems that pump moisture into the Central Plains from the Gulf also generate strong southwesterly winds on their western and northern flanks across the southern high plains of Texas, Oklahoma, and New Mexico. In those regions where the terrain is elevated, the soils are drier, and the vegetation is sparse, those winds can create explosive fire weather conditions with extraordinary speed. The late May outbreak that produced the EF3 tornado in Nebraska also fueled rapid wildfire growth across the southern high plains. That dual threat character, severe storms and violent tornadoes on one side of the system, critical fire weather on the other, is a recurring feature of the late spring atmospheric pattern across the American interior, and it requires emergency managers in both regions to be simultaneously active and coordinated. The Atlantic dimension of the threat now demands attention in a more immediate sense because the Atlantic hurricane season officially opened on June 1st, and the early season threat period has historically been characterized by a specific type of dangerous scenario. The National Hurricane Center and the AccuWeather Seasonal Forecast team have both noted that the early portion of the hurricane season is when homegrown development is most frequent. This refers to the process by which a frontal system or a disturbance that crosses North America stalls over the warm waters of the Gulf of Mexico or the Western Caribbean and gradually acquires tropical characteristics. When storms develop so close to the coast in this way, the lead time available for coastal residents to prepare is dramatically shortened compared to the weeks of tracking that a classic Cape Verde hurricane affords. A system that organizes over the central Gulf of Mexico can be at hurricane strength and making landfall in Louisiana or Texas within 48 to 72 hours of showing organized convection for the first time. Residents of the Gulf Coast states, who may be breathing somewhat easier because the official seasonal forecasts are pointing toward below-average Atlantic hurricane activity overall, need to understand exactly what that framing means and, more importantly, what it does not mean. A below-average season is defined statistically against a historical baseline. It does not mean no dangerous storms. It does not mean no direct US impacts. NOAA itself has been categorical about this. Neil Jacobs made the point as plainly as any government official can make it. It only takes one storm making landfall in a densely populated coastal area as a Category 3 or Category 4 hurricane can produce a disaster of a scale that makes the entire seasonal forecast number irrelevant to the families living in the impacted zone. I want to say one final thing before we close, and I think it is important to say it directly. We have covered a great deal of scientific territory in this documentary, from the physics of supercell formation to the thermodynamics of the Gulf moisture plume to the probabilistic frameworks of seasonal hurricane forecasting. All of that is real, it is verified, and it is drawn from the work of dedicated scientists and meteorologists whose professional mission is to understand these systems and communicate their dangers accurately. But I would always encourage you to take what you hear here as a starting point for your own exploration, not as the final word. Check the National Weather Service website. Look at the Storm Prediction Center's current outlooks. Follow your local NWS office. Read the official NOAA seasonal forecast documentation. The sources are public, they are free, and they are authoritative. The goal of Skyspace Lab is to help you understand why those sources matter and what the information in them means, not to replace your own critical engagement with them. What all of this adds up to, when you step back and look at the full threat picture that America is navigating right now, is a season of compounding and overlapping risks that demand sustained, serious and active engagement from every person who lives in a region that severe weather, tornadoes, flooding or tropical systems can reach. The atmosphere knows none of this. It follows its physics with perfect indifference to the lives and communities in its path. It will continue to generate supercells and tornadoes and derechos and flash floods, and, in the months ahead, tropical systems with the same relentless consistency it has always shown. What we get to decide, as individuals and as communities and as a nation, is how well we use the extraordinary scientific tools now available to us to see the threats coming and protect the people who are most vulnerable to them. The National Weather Service will keep issuing its forecasts. The Storm Prediction Center will keep publishing its outlooks. The science is doing its part. The storm is targeting America right now. What happens in its path is up to us. If you found this research valuable, please take a moment to like this video and subscribe to Skyspace Lab. We are a new channel, and every single one of your subscriptions directly allows us to continue bringing you this level of depth and detail on the stories that matter. Stay aware, stay prepared. I am Arthur. This has been Skyspace Lab.